2.2 is just going into a little bit more detail of reading the energy diagrams or energy profiles that we first came into contact with in Unit 5. So just remember that an energy profile of a chemical reaction gives lots of information. It tells us if the reaction is endothermic or exothermic. Remember that when the products are lower than the reactants, it would be exothermic because you're losing energy, and endothermic is when the products are higher than the reactants. And so if you were actually given data, actual numbers for your axes, then you can find out a lot of information. So that's what we have in example 2. So we have this energy profile diagram, and we want to answer all these questions. And in your notes, it is on page 6 and 7. I couldn't get it all to fit on one side, sorry. So first of all, we want to know the enthalpy of the reactants is about, now remember reactants are here, products are over here. So we could say that's about 80 kilojoules. Okay, so then the enthalpy of the products would be about 160 kilojoules. Activation energy. Remember, activation energy starts at the height of the reactants and goes up to the products. Now, or it goes up to the highest peak. It is not going to be 240 because the energy required is just the distance, the amount between those 2 points. So for the activation energy, we would actually take 240 minus the 80 that we started with, and that would be 160 kilojoules. Okay? The heat of the reaction, or the change in enthalpy of the reaction, is about what? Remember from Unit 5 that the difference between reactants and products is the heat of the reaction, or the change in enthalpy. So for that one, we have 80 and 60, so, or 160 minus 80 would be 80. Now, when you're figuring out the heat of reaction, we also have to think about the sign on the value. Is it going to be positive or negative, depending upon what the, if it's endothermic or exothermic. So in this case, it is in fact endothermic, so we would leave it as a positive 180. And that answers the next question. The forward reaction is endothermic. Now, if it was exothermic, then we would have to put a negative sign on there for the heat of reaction. But since it's positive, it's endothermic, it's positive, like that. The addition of a catalyst would lower which part? Remember, it does not change the reactants or products. What happens when you add a catalyst is it lowers the peak. So that would change the activation energy. So it would lower, I'm just going to say EA for activation energy. So the enthalpy of the reactants is less or greater than the enthalpy of the products. Well, the enthalpy is just the energy height, and the reactants is less than that of the products, so that it will be less. That also fits in with the whole endothermic versus exothermic reading of the graph. Number 8, true or false? Addition of a catalyst will change the value of the delta H. That is false. It changes the activation energy. The heights of reactants and products will stay the same. What will be different is the peak. Number 9, true or false, the addition of a catalyst will change the value for the enthalpy of the reactants. That is false. It will start at the same value each time. And number 10, true or false, addition of catalyst will change the value of the enthalpy of the products. Again, that is false. It only changes the activation energy height. So that is how you could read one of these profiles. Now let's draw one. So we want to draw an energy diagram for the reaction where we want to label the axes with this information. Okay, so you might see different things on the x-axis, so I'm just going to label it like the last example as a reaction coordinate. And then on the y-axis, this is the energy or enthalpy, and that would be kilojoules per mole or kilojoules. I'm going to say kilojoules per mole because all of our units are kilojoules per mole for this problem. Okay, now noticing the values of the, these are the products and these are the reactants, 250, 350. So I'm going to make my axes go in increments of 100. So we'll say that this line will be 100, 200, 300, 400, and 500. Seems like I have enough space. Okay, so the potential energy of the reactants is 350. So starting at 0 on the x-axis, around 350 would be right here. I'm just going to draw out so I know that this flat area is reactants. Okay, and then I know that the products are at 250. So going to 250 and going over to the other side. Let's make that right there. Now that's eyeballing. Okay, that looks good enough. So that's the products. Okay, and then the activation energy is equal to 100 kilojoules per mole. Now, remember in the last example, in order to figure out the activation energy, we had to subtract how high the peak went minus where the reactant started. So, in order to figure out how high we need to make the peak, we need to add those together. So, if the reactants start at 350 and the activation energy is equal to 100 kilojoules per mole, then that means that the highest peak will be at 450. So our peak needs to go to 450. So I'm going to put a dot right there around 450-ish, and then now we're just going to complete the curve. So now, don't judge me on my peak, but that's not too bad. Okay, and this shows that the activation energy is equal to 100 kilojoules per mole. Okay, because that's how high we did that. Now, it's not a part of this, but we could still figure out what the change in enthalpy is, or the heat of the reaction, right? Because we know those data points. We know for the heat of reaction, and I'm just writing over here because I don't have very much space, that is the difference between the reactants and products. So reactants was 350 kilojoules per mole and products were 250 kilojoules per mole. So that would be a subtraction of 100 kilojoules per mole. But is this endothermic or exothermic? This is exothermic because the products are lower. So for the actual value, when you report the change in enthalpy for the reaction, you need to make it a negative 100 because you have to show on that value that it is an exothermic reaction. Okay, so this is just kind of putting into more of what we learned in 6.1 with 6.2 and reading these diagrams.